Okay, so hello everybody and welcome. My name is Corvin. I'm a tech lead at Agile. I started my career as an Android developer 10 years ago, then moved into backend development in 21. And now as a tech lead, I get to do a bit of everything. And I do this at Agile. Agile is an ad tech company from around the corner here in Hamburg. We've been around since 2018. Started quite small, as it started with just a handful of people, but over the years we scaled quite a lot to now more than 100 people, and we are operating worldwide. What does it mean for us that we operate? Well, imagine you're an app developer. You have developed an app that you would like to monetize. You want to make some money with it. Or you're on the other side, you have your app and you want to advertise. You want to make it more popular, want to acquire more users. In both cases, we can help you because we are building the technologies that connect advertisers and monetizers by showing apps in mobile ads. And this might sound a bit boring because nobody, I think, really likes those ads that are always annoying and popping up between levels. But I can tell you that actually building this stuff is far more interesting, far more fun than watching them. The thing is, to be able to do this, we of course have to be integrated into those apps. And for that, we have developed a range of SDKs. We are supporting, of course, the major platforms, Android and iOS, but also the most popular cross-platform frameworks, like, for example, React Native, Flutter, and of course, also Unity. And one thing that has always been very important for us in the development of our SDKs as front-end applications is having good and proper code obfuscation in place. And so today, I would like to tell you a bit about our journey that we traveled for using code obfuscation, tell you about our learnings that we had, what is it, why do you even need it, and I'll also try to give you some guidelines on how you can use them in your own applications. First of all, I would actually like to know, is there anybody here that has already used code obfuscation? Okay, so there are some people, but it's also new to many people. That's good. One small word of caution, you will notice that all the examples and so on in this talk are tailored to Android and Kotlin. That is because Android is one of the most popular front-end frameworks today with the most users. It's also very important to us at Agile. And it's also actually quite simple to show examples for Android. That's why everything you'll see is in Kotlin. However, you can use the same concepts, of course, for basically any language and framework. So you will still be able to apply this to whatever technology you are using. So please take a look at the screen. And now I would like to know who can tell me what this code is doing. Anybody? No? That's good. That's actually what I wanted to see. So don't worry, you failed successfully. I'll give you another chance. What does this thing do? That's not a trick question. That's actually the question I'm asking. Okay, so I see some people understand. I'm giving you a solution. It is calculating the average of a list of inputs of numbers. And I think that's what everybody here thought. It might no longer come as a surprise to you that these two examples, these two pieces of code I've shown you are actually doing the same. The only difference being that the first one, the complicated one on the bottom, has been obfuscated. And this is exactly what obfuscation does. It makes it harder to read, as you could just experience firsthand. And I'm sure you probably didn't really like reading this large piece of code because that's not what we're used to. We are used to writing good code, understandable code, maintainable code. And that's the exact opposite of what obfuscation wants to do. And therefore, it's also a good way to approach obfuscation. Just take everything you know about writing good code and completely reverse it, write the ugliest code that you can. Now that we've seen at least the first example of obfuscation, I think there's a very valid question that many of you will have, and that is, why do I even have to do this? Like, why do I have to throw all my principles overboard and write ugly code? That's not what I've trained for. There are several reasons, I think, for obfuscation. But I think probably the most important one is the improvement of the security of your application. You see, in the front-end world, where also mobile applications reside, you always have to give your application to the user. In the backend, it's quite simple. You just deploy your application on the server, and users interact with it by sending data to it, and you have full control over your application. In the front-end world, you have to, for example, on Android, you upload your app to the Play Store, user goes to the Play Store, downloads to the phone, and from that point onwards, they can literally do anything with it, what they like. So they can reverse engineer your application, they can figure out all the APIs you're calling, be it public APIs or also internal APIs. And this is the critical point, because you'll have to reveal some of your secrets in your code. To my knowledge, there is no way to absolutely protect yourself from doing that, other than just not putting the code there, but then it's of no use. So you have to put your code into your application. But you can help this. You can obfuscate your code, which will make it harder to read. And therefore, it will be more difficult for third parties or for anybody that's reading your code, and that's not you, to understand what it does and to use it to their advantage. So what you've seen first is what I usually call manual obfuscation. So I went there, I took this simple average function and I complicated it. I added some additional lines of code, I added some dead code, I added a good bit of bit shift magic, and all that, as you could see, made it harder to understand. The thing with that is that I can tell you from my personal experience, because I did it, it's not easy. You will have to think about how you have to do this. You will have to implement it. And most importantly, you also have to test it in the end, because you don't want to change the output of your function. You have to make sure that what you obfuscated is still doing what the non-obfuscated function was supposed to do. Luckily for us, there were people that felt the same pain as we are doing with manual obfuscation, and even more luckily so, there were software developers. And one thing that software developers like to do is automating things. So what you get when you take manual obfuscation and you automate it is what I'm calling automatic obfuscation. So basically, you have a program that runs over your code and applies something. We'll take a look at this in a second. There's one more thing that I would like to show you today, and that is obfuscation through native code. And I think this is something that many people don't immediately think about when they hear obfuscation. I admit that this one might be something that is more tailored towards Android than anything else, but there are still concepts that you can apply to other languages. So, like I said, first of all, we've seen some manual obfuscation, so let's take a look at automated obfuscation. And the principle here, like I said, is quite simple. You just have a program that will run over your code. It takes your code as input and outputs code. And that output code should be unreadable, ideally, but still doing the same thing. This is important. There are many programs that can do it. I listed here some that are, again, mostly for Java, Android, or any JVM languages. There are also tools, of course, for other languages. There are both open source free tools, paid commercial tools. You can choose whatever you like. One thing, again, coming back to Android, that is very popular there, you might have heard about this, is ProGuard. ProGuard is the default Android obfuscator. It comes bundled with the Android development toolchain. It is by default activated inside Gradle. That means it's super easy to use. You don't actually have to do anything in order to use it. And what ProGuard does is that it gives you a good baseline obfuscation. What do I mean by baseline obfuscation? To illustrate this, take a look at this example. So here I have written a simple Fibonacci function, and I've obfuscated it with ProGuard. And if you compare these two, you'll notice that basically the only thing that ProGuard did was change the method name. Actually, this is a really good start because, again, we are used to writing good and understandable code, which usually involves giving good, meaningful names. So like this usual example, don't name all your variables var1, var2, I, j, k, whatever. And if you then change these names to something that is I, j, k, whatever, then yes, you already hide to some degree what this code is supposed to do. But actually, apart from that, ProGuard didn't really do much in terms of obfuscation. You can see that, for example, also the variable, the internal variable names, function parameter names have been changed. But actually, the thing here is Prograd didn't change them. It removed them. And what you can see on the right-hand side is what the decompiler added, because, well, you have to see some names here. So it just made something up. But all the other changes, this is basically just the compiler and decompiler removing or basically desugaring the Kotlin syntax. And I think if I gave you some time to figure out what this does, you would be able to do it. Maybe you wouldn't be able to immediately say that, yes, this is a Fibonacci function, because you would have to know the algorithm, but you would be able to tell for an expected input what the output would be. And again, this is why I'm calling it based on obfuscation. It does the first step, but it doesn't really go any further. If you want to go any further, and again, this now applies to really all obfuscators, you'd have to use some other obfuscator. And what they all have in common is that they use a certain set of techniques. And I would like to present to you today 3 techniques which I think are the most common ones and also the most powerful ones. We already talked about renaming. Renaming is actually an obfuscation technique. At least you can see it as such. There are 2 other techniques. One is control flow obfuscation and one is string obfuscation. Let's cover them now. We start with the control flow obfuscation. So if you think about control flow obfuscation, how you can try to understand it is basically as a maze. So when you're in a maze, you connect the input, the beginning, with the end, the output, not with a straight line. That would be the direct way, the obvious way. But you add distractions. You add, for example, some paths that lead to nowhere. You add a few curves that are just not needed. And this is exactly the same principle that we want to apply for control flow obfuscation. We want to essentially move our statements in the code around so that they appear in a different order, but they are still executed in the same order. Because if they were executed in a different order, the output might change, and this is not what we want. So let's take a look at how control flow obfuscation can work. Again, there are lots of different ways how you can exactly do it, but I've highlighted here a few ways that are very common for control flow obfuscation. So first of all, when you take a look at what is highlighted in yellow or in green, this is dead code. So it looks genuine, right? There's some nice if conditions, and they compile fine, there's no syntax error, but they actually don't do anything. So if the condition is true, they don't do anything. If it's false, well, then they anyways don't do anything. That's the nature of an if condition. And what also, for example, makes the yellow code look more genuine, appear more genuine, is that it uses a global variable, the var1. This is also a nice trick, because by adding this, like I said, it just looks more genuine, because these global variables, they're global. They can be also used in other functions, and they are often used in other functions. And they can even be changed, as long as they're just used inside of that code. So you can give them, or the obfuscator can give them any value during the runtime of your program. If they're used in that code, well, it's that code, it doesn't do anything. So you can do whatever you want. Another thing that control flow obfuscation often does is hiding constants. Constants are always nice. They should tell you what is going on. So we want to hide them. And as you can see here in this example, we are using the constant 0 to get the first element of our list. And this is hidden inside the code that's highlighted in blue. So instead of just writing 0, we are starting with 1, and then we have a loop. This loop looks like an infinite loop, right? Because it's while true, so the condition is always true. This would, of course, be not so nice if we put an infinite loop into our program, so we have to break it at some point. And it breaks actually after the first iteration, and in each iteration it just reduces the initial variable with the value 1 by 1. So we get 0, and we are where we want to be. Also, you can see there's another while loop, an outer while loop, that again looks like an infinite loop, but if you follow the code a bit further, you will notice it again breaks after one iteration, because there's a break statement and also a return statement. And this, again, this is basically control flow obfuscation in a nutshell. So you're adding a lot of distractions, a lot of code that looks genuine, so that when you read it, you'll have to process it. You'll have to think about what it does, because only this will tell you whether this is actually genuine code, if it belongs to your application, or if it's just fake code that doesn't do anything. One thing that you will notice in this example that has remained unchanged is actually the text, the string, hello code talks. And this could be a big problem, because strings are in general a very good indicator of what your code is doing. Think about logs. Logs should always tell you exactly what your code is doing at this point in time, at this point of execution, otherwise they would be quite useless. With logs, it is maybe a bit easier, because you can, of course, remove them from the application. They're usually not strictly required for the program to work perfectly well. But there are other strings that you cannot remove, like this one. I mean, I wanted to set the text to hello code talks. I cannot just remove that string. Then the text view would be empty. So in order to help with this, you'll have to use another technique, which is the string obfuscation. And string obfuscation is basically string encryption. So you encrypt your strings at runtime, and then you have a decryption function that decrypts the strings you encrypt at compile time and you decrypt at runtime. That's the recipe. There are, again, I'm sorry to say this again, but there are lots of ways how to do it. So I can't go much in detail here, but the general principle is that usually you will have some kind of lookup table. This lookup table is a byte, string, character, array, whatever, with seemingly random inputs or values. And then you have some function that works on top of that lookup table, and it takes some inputs and produces an output. And the output is the unobfuscated, the decrypted string. The point about this lookup table function, or this decryption, deobfuscation function, is that it always has to take some inputs. It has to know where to start in order to go over this lookup table and do some stuff. And these inputs, again, they look seemingly random. Of course, they have to be chosen quite carefully to give you the correct output. So you can see here, for example, the -49 or that huge number at the top. Yeah, it looks just completely random, but it's actually there on purpose. What this type of string obfuscation, or obfuscation in general, also did is one nice little detail, because it also added to each of those constants the output of a system call. So remember from the control flow obfuscation slide before, with the hiding the constants, this is again what we're doing here. So we have a constant, the number, and then we add another value. And this makes it again look more genuine. You will think, okay, this is an actual piece of code, I'll have to understand what it does. However, the thing about those system calls is they're usually just constants themselves. So for example, this code highlighted in red, this is just the value 0. And in fact, most of those constants will always turn out to be just -1, 0, or 1. And yeah, this is, again, string obfuscation in a nutshell. Like I said, there are lots of ways how to obfuscate your string, because in general it is string encryption. So you can even use something like AES, and it will work as a string obfuscation. Okay, so we have seen now a few obfuscation techniques. And I would like to come now to one point that I really enjoy, and that is some hacking stuff. So with all of this in mind, knowing also that ProGuard doesn't do much more than just renaming, wouldn't it be cool if we can write our own obfuscator? And in fact, we can. Again, sorry, this is Android, but again, the general idea is you just have to write a program that takes code as input and outputs code. The principle is always the same. I'm going to show you how you can do it for Android. So on Android, the build system is called Gradle. This makes sure that your apps are built. They always that you have consistent builds. It also provides configuration of the builds and so on. Gradle is extendable by plugins, so you can do your own custom stuff, like creating your own, like obfuscating code. So in order to create a Gradle plugin, all you have to do is implement the Gradle's plugin interface, which has exactly one function, the apply function, that we override. And in that, we add a transformation on our code. And in this case, the transformation is specified by the visitor factory, which again has just one function that we need to override, super simple. And this function has to return a class visitor, and we'll return it in class remapper. That sounds fishy, right? So we want a visitor, but we return a remapper. In order to understand this, I have to tell you what I want to do with this obfuscation. There are two things. First of all, I want to rename method names. Yes, this is also what Progra can do, but it's just a good example. And again, renaming things is always a good start. Secondly, I want to add some dead code. I want to add some dead code to every function that just sits there in the first line, just as a proof of concept. The cool thing about this library that we can use in Gradle is that the renaming stuff is already built in the form of a remapper. That's why I'm using here the class remapper instead of the simple class visitor. It just extends the class visitor, so we're all good. There are two things I would like to point out here. First of all, the if condition. This is important. This makes sure that I apply the obfuscation only on classes that are inside my namespace, because otherwise I would end up obfuscating the whole application, which includes system libraries, it includes third-party libraries, and this would just break it. So we have to restrict ourselves to our own namespace. A second thing, there are three very nice letters that I would like to point out, and that's the letters ASM in the name of the extending class. ASM, this indicates that we are actually working on the bytecode instead of the source code level, and this is important for obfuscation. You remember again the first code example, the one with the long code that is hard to understand. This was done on the source code level, which meant, yes, I obfuscated for everybody, but everybody includes myself and my coworkers. So if I do this, well, nobody will be able to read the code anymore and to maintain it. And therefore, obfuscation is usually not applied on the source code level, and at least not before compile time, but it should be applied at compile time or after compile time, and ideally even on a lower level, on the bytecode level. And this is what we're doing here. Okay. Enough of that, let's rename some stuff. For this class remapper, it is super simple. We have to override only one function to create a method remapper, because in this case we only care about methods. It's just a class we override. Let's take a look at this obfuscation remapper that we're passing. It looks like this. This obfuscation remapper overrides again just one function to change method names. And here, we are replacing the letter I with U, just for fun. This is a simple renaming. Of course, it's reversible, so it's a demonstration. And again, we have to pay attention to what we're obfuscating. We don't want to obfuscate methods that are not owned by us. So we could still have system functions inside our namespace that are not owned by us. And we also, of course, don't want to obfuscate the Java constructor or the static code initializer, because this would again break the code. But with that, the first part is done, and I no longer have to say remapper. Coming to the second part. Actually, okay, sorry, there's one more remapper. Because we also want to add some dead code, and this is inside our beautiful method remapper. How does it look? Now comes the bytecode. Actually, I'm wondering, does anybody here use bytecode or machine code on a daily or regular basis? One, almost. Okay, so two, nice. For all of those that are not any of those two guys, quick refresher of what bytecode and machine code and so on is. That's the stuff that you probably, like me, heard about last at university, and you then hopefully, or you try to forget about it. That's basically this children's playground where everybody's jumping around and you stack things on top of each other and everybody likes spaghetti. And also a good reason why you should use something like Java or Kotlin or any high-level language. It's still fun, yeah. So, I said I want to add some dead code. I want to add it in the form of a while loop that never executes. For that, let's briefly recap how loops look in bytecode. So how it works is you always have to define your start point. And at that start point, you set a label. So you fix this point. And then, like I said, bytecodes, by ready code, you just go line by line. You execute all your statements. And at some point, there should be a jump statement. And the jump statement jumps to a label. And if it's the label we defined before, then we've completed our loop. We can go down, we jump up, go down, and so on and so on. Until at some point, we should hopefully break our loop, because otherwise it becomes an infinite loop. So now that the concept is clear, we can take a look at how this is done in practice for our loop. So we have to define the label first. Then we have to, since we want to add this mathematical condition, we have to push a few numbers onto the stacks. We're pushing first the number 42 onto the stack, then we're pushing number 2 onto the stack. We are calculating then the remainder of the division of those two numbers. And then there's a very nice bytecode instruction that does a lot. Because this if and e, whatever, this does a lot of things. So first of all, it takes the result from the last instruction, the remainder calculation. It will then compare it to 0. And if the result is not equal to 0, it will jump to the label that we supplied, label L0, which is the top, so we have completed our loop. And that's it. And since I want to add it to every single function, I'm adding this code inside the visit code method. And when this bytecode is added, I just have to visit the rest of the code, so the actual code of the function, and that's it. So that was a lot. Actually, not. But yeah. What do you have to do now? There are two things left. Since it's a Grader plugin, we have to actually register it inside the build system. This is quite easy. It's just a few lines of code. And then applying it is even easier because, well, Grader comes with all that stuff built in. And then we can hit the build button and see what it does. Ta-da! We obfuscated our code. So actually, nobody can read anymore what it does, right? Great. Yeah. So obviously, this is just a demonstration. We could go much more in detail here to create a more powerful obfuscation, but this should show you how you can approach building your own obfuscator and how easy it can actually be to get started. Apart from being fun, writing your own obfuscator can also be quite useful, because for all those public obfuscators or open source, paid, whatever, everything that's out there, there are often already deobfuscators available. Deobfuscators can deobfuscate, reverse your code to make it readable again. And by writing your own obfuscator, you can actually implement algorithms that are not yet implemented by, or not yet decoded, not yet in any public deobfuscators. And I would like to talk about deobfuscation for a second here. So deobfuscation, as maybe the name indicates, is the process of reversing an obfuscation. So you have your ugly, unreadable code, you want to make it readable again. That's why you use deobfuscation. Deobfuscation is somewhat similar to obfuscation. So you have basically two ways to do it. You have the manual way and the automatic way. However, what I think is the most powerful way is when you combine these two. So you will probably have to use an automatic deobfuscator, because this will just make sure that you can apply it to all your code at once. But you will have to configure it. And for the configuration, you will have to take a look at the code, try to figure out how it was obfuscated, and then choose the right configuration to deobfuscate it. This is an example of how it could work. I've used the maker.ir deobfuscator to deobfuscate the code that we just obfuscated. And as you can see, it was able to remove the dead code that we added. That's because I added a configuration that should remove dead code. It identified it, removed it, all fine. However, at the same time, I probably overdid it a bit with the configurations, because the deobfuscation process completely broke the function. As you can see now, there are lots of instances where the program is trying to compare integers with class instances, which usually doesn't work. It's also setting the input parameter to 0, which is just not a good idea if you want to have anything variable. So in order to fix this, I will now have to go try to figure out which configuration broke the code, reverse them, run it again, iterate until I have something that is somewhat readable. We're coming towards the end. There's one more thing I promised to show you, and that is the obfuscation through native code. So native code, again, a bit more Android specific here. Native code in Android terms is code that is written in C or C++. It's integrated into Android through the NDK, the Native Development Kit, and this makes it actually quite easy to integrate, although there are still some challenges that you will have to work with, but overall it is no black magic. Let's take a look in a second, just give it some time. So the native code that you would be able to see here, it's actually, it's unreadable, right? Isn't it great? I obfuscated it, nice. Okay, that was a quick deobfuscation. So you can't really read this code. Now that you can read it, you probably can't read it. And this is not even the obfuscated code. This is just the native code. Where the obfuscation comes in now is actually the compilation and then decompilation, actually disassembly. So when we take our normal Kotlin code and compile it, decompile it, we get what's on the left-hand side. And yes, I think we can all see what it does. If we take our native code, compile it, decompile it, disassemble it, we get what we have on the right-hand side. And even, I mean, I'm not showing you all the internal functions here, but I think even if I were to show you those, it would still be a lot of work for all of us to figure out what this does. And this is where native code can be used as obfuscation. So it just adds this additional layer of the difficulty of decompiling, disassembling native code, machine code, which is even one level lower than the Java bytecode. Like I said, there are some challenges with native code obfuscation, like that there's no slide, for example. But for example, you have to take care of memory management. You'll have to make sure that the communication between Java or Kotlin code and native code works correctly. So you'll have to use it with caution. We are at the end. Let's wrap it up. So I promised you that I would give you some guidelines of how you can approach obfuscation in your own projects. And what I would always suggest is that you start with automatic obfuscation, because this is always the easiest to get started. There should always be some program that can just obfuscate your code. It just depends on the level on which it obfuscates the code. You might have to rely on something paid or commercial, not just the open source ones, but it will still get you a good way towards your goal. What you can do if you don't want to use any paid program is that you can always use manual obfuscation. So you can always just write your code ugly. Sometimes you even do it involuntarily. But this you can use as an obfuscation. And the cool thing about this is that you can be very specific about which functions you can obfuscate and how you obfuscate them. Again, the downside is that you usually would obfuscate the source code, which makes it unreadable. So you have to really take care of maybe having a copy of the actual code somewhere and then having the obfuscated code in the source code just to be able to still maintain that code. If there's, again, some parts of your code that you want to obfuscate and you don't want to obfuscate it manually, but you want to have really powerful obfuscation, you can opt for something like native code obfuscation. Again, basically any language should support something like this, if it's not already on the machine code level. This will give you a more powerful obfuscation than your normal bytecode obfuscation. But like I said, it comes with a few challenges. So you should be careful where you use it. You have to be a bit selective. You don't want to write your complete Android application, for example, in native code, although it works. But it's not what you want to do. Again, there's a reason why there are languages like Java and Kotlin. But yeah, I think this is basically what I would suggest you for obfuscation. And with that, I've arrived at the end. I hope you enjoyed this. If you did and you want to hear or read more like this, then I can recommend you our engineers blog. This is where the Agile developers write about their daily development encounters. And if you're interested in the code examples, or you want to, for example, see a project, an Android project where all of this is used in practice, you can check out that GitHub repository. You can also find there more resources to read more about obfuscation. And if you have any questions, then you can, of course, always write me an email. You can also visit our Agile booth. I will be there today and tomorrow, and I can answer your questions about anything, not just obfuscation. And I think we still have a few minutes left, so I'm also happy to answer your questions now.